Hello class, this is Geometry Topic 7-2 over Pythagorean Theorem. When three sides of a right triangle are known, when two of the three sides of a right triangle are known, the third side can be found using Pythagorean Theorem. You've been doing this for several years. This is not anything new. Now the Pythagorean Theorem says that the square of the hypotenuse is equal to the sum of the square of the legs. Hypotenuse squared equals leg squared plus leg squared. That's one of our legs. That's the other leg. And this is the hypotenuse. Notice the hypotenuse is opposite the right angle. That way you always know which one's the hypotenuse, and the legs don't really matter. We're going to call this side A, B, and C. And C is always the hypotenuse. So when we do that, Pythagorean theorem turns into a squared plus b squared equals c squared. Or, say you're given the hypotenuse, you can do c squared minus a squared equals b squared, and you can use this if you like. Personally, I prefer to always use the top one. So that's what I'm going to use. You may be comfortable using this, but I will not be showing it to you in our problems. Let's go ahead and take a look at example number 1. Well, A and B and C so 7 squared plus 3 squared equals x squared. There's 49 plus 9, which is 58. I'm going to do the square root of all of those. And so we say the square root of 58 is 7.62, about. So x is about 7.62. Notice how this third point is a 5. Because it's a 5 or larger, it will round this second one up. Just basic rounding again. Let's go ahead and do example number 2. A, B, and opposite the hypotenuse is C. So know that 6 squared plus x squared equals 6 on the square root of 2 squared. Well, 6 squared, we know that's 36, plus x squared, we can't do anything with that, equals, let me show you what happens when we do this in the calculator, and then I'll teach you how to do it without the calculator. If I do 6 on the square root of 2, now I encase it all in parentheses, and then I square it, I get 72. Another way that I could do this is I could do 6 squared plus times the square root of 2 squared, which would be 36 times 4, which also equals 72. That's 36 times 2, which also equals 72, because the square root of 2 squared is 2. So, if you want to be able to do this in your head, you can just do 6 squared is 36 times 2 makes 72. But that's not what we're trying to go for. We're trying to figure out what x is. So, we're going to subtract 36 from both sides. We get that x squared equals, well, 72 minus 36 happens to be 36. Then we take the square root and we get that x equals 6, because the square root of 36 is 6. So, even though this picture doesn't look like this leg and this leg are the same, because of the way that it's labeled, we know that x is the same. Let's go ahead and see if we can do this some more. Well, we don't have a triangle, so you say we can't use Pythagorean Theorem, when in fact, we actually do. I have a side right here. And I know how long this side is because it's the same length as this, so this would be 8. And I can figure out what this piece is because I know the whole thing is 11, but this part of it is 5. And so 11 minus 5 is 6, so that means that this piece is 6. So 6 squared plus 8 squared equals x squared, because that's my hypotenuse. 36 plus 64 equals x squared. 100 equals x squared. So x must equal 10. Alright, so we didn't force this, we turned this into a square with a right triangle, or a rectangle and a right triangle, and then we found the side of the right triangle. Let's go and take a look at example number 4. Alright, well, this is a square. I know that all 4 sides are equal, and I have made a right angle right here. So this is a right triangle, and I know that this has to be x, and that has to be x, and it says my hypotenuse is 5 on the square root of 2. So x squared plus x squared equals 5 on the square root of 2 squared, which makes this 2x squared equals, well, I can put this in the calculator, 5 on the square root of 2 in parentheses and square it, or I can do 5 times 5 is 25 times 2 makes that 50. And to prove to you that works, 5 on the square root of 2 squared is 50. So I need to divide by 2. X equals 25. Sorry, x squared equals 25. Do my square root. The square root of 25 is 5. So x must equal 5. So that was example number 4. Now for example number 5, we're going to need to draw our own picture. It says find the length of the diagonal of a rectangle with a length of 8 and a width of 4. Well, this is just a right triangle where that's my hypotenuse. So 4 squared plus 8 squared equals x squared. 16 plus 64 is x squared. 80 is x squared. We'll take the square root. And this time, I'm not going to use the calculator to solve this. I want to show you how to simplify a radical. This should have been covered in algebra, but you may not remember. So what can I take and divide 80 into? Well, I know that it's 10 and 8. Well, 10 is 5 and 2. 8 is 2 and 4. And 4 is 2 and 2. We've got a pair of 2's. I've got another pair of 2's. I've got a 5 left over. So that means that 80 is the same as 2 times 2 times the square root of 5, which makes that 4 on the square root of 5 equals x. And this is the more exact answer. Were I to do that in the calculator, the square root of 80, I would get 8.94 roughly. And if I do 4 on the square root of 5, notice I get the exact same answer. So this is a better and more accurate answer than this, because this is an irrational number that goes forever and never repeats. I will accept both answers, but this one is better, and if you had to use this diagonal to find something else, this will give you a better answer at the end. Let's go ahead and look at example number 6. Find the length of the diagonal of a square not terribly good at drawing my squares. And I know it's a square, so I know all those are the same, and I know that that's a right angle. And the perimeter is 24. Well, the perimeter being 24, I need to find the length of one side. So 24 divided by 4 is 6. So the length of each side is 6. So we do 6 squared plus 6 squared equals c squared, because that's my hypotenuse. 36 plus 36 equals c squared. 72 is c squared. Take the square root. Again, let's go ahead and simplify this. Well, no, this is 36 times 2. That is 6 times 6. I've got a pair of 6's with a 2 left on the outside. Means that this is 6 on the square root of 2 equals c, which is the length of my diameter. Alright, last example, number 7. I want to figure out the value of x. And it tells me this is an isosceles trapezoid, and it shows me that these are the same. I know that this piece is 10, but I need to figure out what these smaller pieces are. Well, let's go ahead and just call this A. I need to figure out what A is. Well, A squared plus 8 squared must equal 10 squared, because 10 is our hypotenuse. So A squared plus 64 equals 100. Subtract 64, and A squared equals 36. We take the square roots, and we find that A equals 6. But that's not our answer. We don't want to know what A is, we want to know what x is. So this piece is 6. This middle piece is 10. And this piece is going to be the same, so I know that it is also 6. So 6 plus 10 plus 6 is 12 plus 10 is 22. And so our answer is 22. So, again, on these, where we have a irrational square root, I'm okay with you writing it like this. I am also okay with you putting them in the calculator and just rounding off to 2 decimal places. So, hope you have a good day and good luck on your assignment.